This is one of the lesson videos for 5-6. It's going through some of the related rates. We're looking at number 4 about the police car that's driving towards the angled intersection where there's a car chasing that it's chasing that's speeding away from it. So as the police are moving this way, we'll call maybe their path Y, the speeder is moving this way, we'll call their path X. And then we do need to relate the distance between the two vehicles because they refer to it. So I'm calling that Z, and you may call it whatever you'd like. So as we've gone through and we've used the template to see some different decisions and some different steps we should be taking, you can shorten that down a little bit once you're familiar with it to PIG or PIG. What's permanent? What's instantaneous? What am I trying to get? So first, as I read through, it appears that what I'm trying to get or find is the speed of the car, but at a really particular instance in time. So I'm looking for dx dt, the speed that that car is moving away, at a time when, and it says the time when the distance between them, the police, and the car is increasing. So the distance between them at 20 miles per hour, and the distance between them is dz. So when the rate of change of dz is 20 miles per hour. So going through that, when dz is 20 miles per hour, they also said that at that time, when the police officer is 0.6 of a mile to the north and the car is 0.8 of a mile to the east, the distance between them is increasing at 10 miles per hour. They're telling me more about what's going on just at that instance. And then we'll have to read through and find out what we know is permanent or fixed information as well, because all of those things are going to help us with the variables that we've got to get into all this situation. So at that instance in time, when dz is 20 miles per hour, we know a few more things about what this picture looks like. We also then know that our y value is 0.6 miles, our x value is 0.8 miles, our z value, if you do a little Pythagorean theorem, turns out to be 1 mile. So all those would be true at that instance in time. Things that I know that are fixed or permanent, there really isn't much in here. Oh, we know one more thing at that time. We also know at that point in time, we know the rate that the police are traveling. And the police are traveling dy dt. The police rate, that y is getting smaller as the police travel towards the intersection. So that rate is -60 at that instance in time. There's not a whole lot in here that's fixed. And sometimes that will happen. So the equation that relates those three variables that all this information is about would be the Pythagorean theorem one. So as we go through and work our derivatives so that we've got those rates in there, we start putting in rates in relationship to time. We're going to do that implicit differentiation on both sides. Everything with respect to time, since we want rates. When I go down and fill all this in, this is great. A lot of this stuff is working out really nicely. Let's go through though and see if we need to find anything else before we start plugging in. At that specific instance in time, I have x, so I'll be good there. I'm trying to find dx dt, so it's fine that that's a variable. I have y, and at that time I have dy dt. At that time I have z, but I don't have dz dt. So we're trying to find what that is. Well, here's the good news. At that instance, that I know. So I'm ready to go ahead and plug in everything that I know and solve for the one variable that's left standing. So my information is going to say that at that instance in time, when x is 0.8 of a mile, and the police are moving at, we're trying to find dx dt, so let's leave that. Twice the y value times how the y is changing, which is -60 miles per hour, is twice our z value times how our z is changing, 20 miles per hour. Do a little bit of moving around. Solve for the rate you were trying to find. It should come up 70 miles per hour. Then be sure you go back and actually answer the question. The speed of the car, when the police are traveling 60 miles per hour, is 70 miles per hour.